Hello and welcome to the flipped module on parallel circuits. Please make sure that you have seen the flipped videos on series circuits and circuit diagrams before you continue with this. You will have learned that a simple circuit involves a continuous loop from the energy supply, which could be a battery or a number of batteries or a power pack, through conducting wires past components one at a time. Here we have a bulb and another bulb, and then this continues back to the power supply, the power pack or the battery. Here the current has to go through every component as it passes along the circuit. However, with a parallel circuit this is not the case. Again, we've shown two bulbs here, and this time these two bulbs are shown in parallel. So what we notice now is that as the current flows from the battery, it has a choice to go through one or the other of the components, this case the light bulbs that are here. Obviously the electrons don't make a choice, but some of the electrons will go one way and some of the electrons or the current will go the other way. And then these will continue, eventually joining back up together and back to the power supply. In this example of a parallel circuit, we can see that there are two components, or light bulbs in this case, on two separate loops or branches. This doesn't have to be the case. We can have further branches in a parallel circuit, so there could be another component on another branch down here. Or we can actually combine series and parallel together. We could have a number of components on each branch. So there's lots of different ways in which a parallel circuit can be put together. We're now going to examine three advantages that parallel circuits have over simple series circuits. One of the main benefits of having a parallel circuit is that we can include separate on-off switches for different branches or different components. If we have a look at this series circuit here, first of all, we'll see that it doesn't matter where we put the switch. You should know that it doesn't matter where you put the switch. If we turn this switch on, it's going to mean that both of the components, in this case light bulbs, will light up at the same time. And if we switch it off, then both of the light bulbs will switch off. However, with a parallel circuit, if we put our switches in the branches of the circuit, then we can actually have different switches that can control different components. For example, if we turn this switch on, this will light one of the light bulbs, the uppermost light bulb, and likewise if we switch this switch on, then this would light the other bulb. And of course we can also have both of the switches turned on at the same time in order to light both of the bulbs simultaneously. We could also incorporate another switch into the circuit in order to have one switch that controls both of the light bulbs like we have in the series circuit. If we had a switch positioned here, for example, as well as these switches, then we could have one switch to turn one bulb on, one switch to turn the other bulb on, or another sort of master switch that enables the electricity to be shut down completely to any component in the circuit, or allow these individual switches to function and to turn components on or off. So to the second advantage of parallel circuits, and this is that when a circuit component blows, this does not affect other components, or at least other branches of that circuit. We know that there needs to be a continuous loop in order for a current to flow. So if one of the bulbs in a series circuit blows, say for example this bulb blows, this is going to mean that the other bulb, this one that's located here, will go out as well. When the first bulb blows, This stops any flow of current through the loop because the filament in the bulb is carrying the current, and when the filament breaks or the bulb blows, then that current can no longer flow. So this means that any other components in the loop will also stop working because there won't be any flow of current. However, in a parallel circuit, if one of the components on a particular branch blows, say for example this one, then this will not affect any other components. So the other bulb that's down here will continue to flow because we've got this continuous loop allowing the current to flow from the energy source through the component back to the energy source. The third advantage of parallel circuits is that the voltage of each branch is the same as or equal to the power source for the circuit. So if you understand voltage, which you should do from watching a previous module, and if you don't, please go back and make sure you're clear on what voltage is. In a series circuit, whatever voltage we have for our power source, in this example here we've got a voltage of we've got 12 volt power source from maybe a power pack. This voltage is then shared amongst the components of a circuit. So in this example, if the bulbs or the components were equal, they would get 6 volts each. In a parallel circuit, if we have the two components, or in this case the two light bulbs, on separate branches, and each of the branches will get 12 volts, or in this case each component or each light bulb will get 12 volts. This is an advantage when we are adding different components into a circuit, like we might do in a household situation with the power supply in a house. If we're using a series circuit in a house, and you plugged in, let's say for example the TV, and then you plugged in your PlayStation, and then you also plugged in your stereo, each of those different components would have to share the voltage. So we wouldn't know, or the house system would run on a particular voltage, probably 230 or 240 volts, in which case then depending on how many things were added to that circuit would depend on what voltage each of the components got, and different components such as the TV need a very specific voltage in order to work correctly. And so wiring a house up in series simply wouldn't work. You would have to turn the TV on, and then in order to turn your PlayStation on, you'd have to turn the TV off so that you knew that the PlayStation and the TV were getting the correct voltage. Whereas in a parallel circuit, we can put different components on different loops, and therefore then they can get the correct voltage as set out by the household voltage